So today we're going to talk about slope and parallel lines. And hopefully you remember some of this from algebra. But remember that parallel lines are lines that are on the same plane that never intersect. And so we know that parallel lines have the same slope. We learned that in Algebra 1. All right, so let's take a look at how we can prove that parallel lines have the same slope. So in this first proof, we are given that non-vertical lines M and N, and we know that they're parallel. We are given the fact that they are parallel. So now we want to prove that they have the same slope. Okay, so we're going to let points A and B be 2 points on line M. So there's A and there's B. Okay, and then we're going to draw a horizontal line through A. So there's my horizontal line through A. And we're going to draw a vertical line through B to create that slope triangle. And remember, we talked about that triangle when we looked at the distance formula. All right, then we're going to look at where our line that we drew through A, the horizontal line, where it intersects line N. And so that is at point D here. Okay. And we are going to continue that till we get to F so that it is the same distance from A to C as it is from D to F. So AC is equal to DF. So we know that these two segments are congruent, AC and DF. Then we're going to draw a vertical line through F that intersects line N at point E. Okay. Now we have two vertical lines. We don't know that those are congruent yet. We have no way of knowing that yet. But we do know that angle BAC right here is congruent to angle EDF because we know that those are corresponding angles because we have two parallel lines with the transversal AF that cuts through the parallel lines. So by corresponding angles, we know that those two are congruent. Okay, so now we can say that the two triangles are congruent because remember when we drew the slope triangles, because we drew vertical and horizontal lines, we know that those two angles, BCA and EFD, are right angles. So now by angle side angle, we know that those two triangles are congruent. Okay, so now, since we know that those two triangles are congruent, we can say that segment BC is congruent to segment EF because corresponding parts of congruent triangles are congruent. Okay, and so if we know that BC is equal to EF, because if the two line segments are congruent, then their measures must be equal. And then we divide those by two segments that have equal measure, then we know that those two proportions are congruent. And so really by the division property, you're basically dividing by equal measures. Then you know that those two fractions or proportions must be congruent. All right, so this shows that the slope of M is equal to the slope of N, because remember, slope is rise over run. So BC over AC is your rise over run from A to B. And then from D to E, you have EF, which is your rise, and that's over DF, which is your run. So we know that our slopes are congruent, or are equal, sorry. Does the above proof work if the lines are horizontal? If not, does the theorem still hold? So go ahead and think about that question. Think about what would happen if your lines were horizontal, and that's talking about lines M and N, and explain your answer there in part 1A. And then in part 1B, how could you estimate the slope of lines M and N? And again, it's an estimation, so you don't need to give an exact number, but you're just talking about how you might be able to estimate. So there is no right or wrong answer, but go ahead and answer those questions. All right, now let's take a look at another proof. This time we are going to say that lines M and N have the same slope, and we want to prove that they are parallel. Okay, so let A and B be 2 points on line M. Draw a horizontal line through A and a vertical line through B to create the slope triangle ABC. Okay, then you're going to extend AC to intersect line N at point D and continue to extend it to point F so that DF is equal to AC. And then you're going to draw a vertical line from E to F, or from F to E, so that it intersects line N. Since line M and line N have the same slope, BC over AC equals EF over DF. And then DF is equal to AC, so we can say that BC over AC is equal to EF over AC. Okay, and then if you multiply both sides by AC, now we have BC equals EF. So we know that those two segments are congruent. And so now we know that our two triangles are congruent, because remember when we were constructing AC and DF, we constructed them in such a way that they would be congruent. And we also knew that we created right triangles. And we also know that these two now are congruent. And so we can say that triangle BAC is congruent to triangle EDF by the side angle side. Okay, because we have AC is congruent to DF. We have angle ACB is congruent to angle DFE, and we have segment BC is congruent to segment EF. And so now we know that angles BAC and angle EDF are congruent because of corresponding parts of congruent triangles are congruent. And so then this shows that M is parallel to N by the converse of parallel lines. Because remember, parallel lines, two lines are parallel if they have the same slope. And so if two lines have the same slope, then they are parallel. So that's the converse of that. All right, take a look at the reflection questions. Suppose you extend AC to intersect line N at point D, and then extend it to form the slope triangle EDF for line N, but you do not do this in such a way that DF is equal to AC. Explain how you could use similarity to complete the proof. So you would, instead of being congruent, they would be similar triangles. So go ahead and discuss with your group and write down an explanation for that. All right, remember the slope-intercept form of a line y equals mx plus b, where m is the slope and b is the y-intercept, because you're going to need to know that information. All right, so now we're going to take a look at the point-slope form. And if you have not seen that, it's just another way of writing the equation of a line using the slope and a point. Okay, and so m is your slope, and x sub 1, y sub 1 is a point that is on the line. Okay, so we want to write the equation of each line in slope-intercept form. All right, so we're going to use some information that's given to us in the problem to figure this out. So in A, the line parallel to y equals negative 2x plus 3 that passes through 1, negative 4. The line given is in slope-intercept form, and so the slope is negative 2, remember, because it's the coefficient of x. The required line has slope of negative 2 because parallel lines have the same slope. So now we have a point that the line passes through and the slope of the line. So we're going to take the x and y values and plug those in. So y minus the y value, which is negative 4, equals the slope times x minus the x value, which was 1. Okay? And so now we get y plus 4 equals negative 2x plus 2. We distribute that negative 2. And so then we are going to subtract that 4 over. So y equals negative 2x minus 2. And so that's the equation of the line in slope-intercept form. Now let's take a look at part B. We want to find the equation of the line that passes through the point 2, 3 and is parallel to the line that passes through 1, negative 2, and 7, 1. So first we can find the slope of this line that it is parallel to, right? We're going to find the slope. So y sub 2, which is 1, minus y sub 1, which is negative 2, over x sub 2, which is 7, minus x sub 1, which is 1. So 1 plus 2 over 7 minus 1, which is 3 over 6, which is 1/2. Okay? So the required line has slope of 1/2. And so now we can use our point slope form to find the equation of the line. So y minus the y value, which was 3, equals the slope, which was 1/2, times x minus the x value, which was 2. And so then we can simplify. So we get 1/2 x minus 1. And then we're going to add the 3 over, so plus 3. So we get y equals, oh, I forgot my x there, 1/2 x So we get y equals 1/2 x minus 1, because we distribute the negative or the 1/2, and then we have to add the 3. So we end up with y equals 1/2 x plus 2 for the equation of the line. So let's take a look at the reflection. In part A, how can you check that you wrote the correct equation? So discuss and answer the question. And then 3B, in part A, once you know that the slope of the required line, how can you finish solving the problem using the slope-intercept form of a linear equation? So go ahead and answer that question as well. And then finally, on the last page, you have some practice problems. So you're going to write the equation of each of the lines in slope-intercept form. And remember that slope-intercept form was y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so you'll want to show your work on a separate sheet of paper.